Hi, my name is Gerald Chikukor. Welcome to my presentation for CSC722 Machine Learning. For this presentation, I chose to look at a paper written by Aaron Rosbaum, detecting credit card fraud with machine learning. His motivation for doing this research was the issue that there is an issue with credit card fraud, and there is a lot of payment data being stolen in terms of credit cards, in terms of different payment systems that are being used nowadays. So that was mostly his motivation for writing this paper and trying to figure out how best can machine learning be used to detect fraud. So in his efforts to do that, he went to look at different methods that he could use. So what he did was he used the sampling methods, simple logic regression, uh, logic regression with quadratic terms, and lasso regularization. He also used random forests. He also used natural networks. So in his efforts to find out what's the best way of looking at things and how can he find a better way of learning this data that he's been collecting. So he had a data set from Kaggle that he had. It had different, it's a big data set, and that's what he was working with in terms of looking through, combing through it, and trying to figure out different methods to go through all this credit data that he had. Whether some of the data set was compromised, some of the data was not compromised. So that's all the data that he had. So that's what he was working with. So for the sampling methods, he used for the training data. So for example, in the training set, you would use undersampling, which is a balance, which is balances the data by randomly choosing observations from the majority class to exclude. And also you used oversampling, balances the data by randomly oversampling the minority class. He used both, a hybrid method that employs both undersampling and oversampling. And he also used the ROS, a systematic data generation method that balances the data by creating artificial samples of the minority class in the neighborhood of existing samples. So when we move on to the simple logic regression, which is widely used in our discriminative learning algorithm that uses hypothesis. And then he also looked at logic regression with quadratic terms and lasso regularization. And then he used the random forest, which is a tree-based model that he used as well in terms of simple regions that can be used to classify the dependent variables. So in that aspect, he also went on to use the neural networks. Neural networks are a popular set of machine learning algorithms that are widely used for credit card fraud detection. Conceptually, a neural network is composed of simple elements called neurons that receive input, change their internal state based on that input, and that produce an output based on an activation function. These functions can learn to detect complex patterns in data without using task-specific rules. So when he went through the results when he went all through all these methods that he used, we come down to the results. So Aaron employed a simply fully connected neural network using NNet package in R. The models fit consist of a single hidden layer. Use the logic activation function to reduce computational complexities. He also selected the number of hidden units to use for all models fit by simply a cross validation for one of the models. He also tested the weights options in the net function as an alternative method for dealing with class imbalances. The weight method directly changes how observations in, in each class are personalized in the loss function. The weight W value was also selected by simple cross validation. So when you look at the results here, you look that after implementing, all the methods that we talked about, we see that Aaron, when he used the simple logic and linear terms only, we see that the rows function performs better than any. It performs better than uh, any other function. It performs better than any other method there. So when you look at the logic quadratic terms with lasso, we understand that the oversampling actually works better than underpinning both hybrid and rows. And when we look down here to look at the results here, we realize uh, Aaron realized that oversampling as well was actually doing pretty good on the random forest as well. So oversampling was actually doing pretty good. And when you look at the neural networks, you realize that the ROS uh, method was actually doing pretty good. So as you look at his results, you realize that the two the two main uh, it looks like it's better off in terms of oversampling, and rows with the ones which are dominant in terms of uh, performing better in all different in all four different models that he used, in all different four methods that he actually used here. Uh, so we can actually simply figure out that payment fraud is significant and growing issues in the United States. Payment fraud is significant and growing issue in the United States, but detecting it can be like finding a needle in a haystack. So when you look at the results, you realize that the way he went through the methods and all that stuff, it's like a needle in the haystack that you have to go through all different methods to find what exactly method that fits for you. The author found out that oversampling and synthetic data generation methods, when tuned properly, can lead to superior predictive performance in the face of class imbalances. Thank you.